What shall I do here? What's my very, very, very first step? I don't know. Thank you. Well done. 10 points to Gryffindor. Okay, now, always do that. Never, just like before we were noticing when you're solving equations, before you even start working, you note restrictions or you draw a diagram, all those kinds of things. With simultaneous equations, labeling them is exactly the same. Okay, before you go anywhere. All right, now, if I'm doing this by elimination, right, and you notice, by the way, I could do this by substitution. I suppose I would maybe divide this equation by 2, this equation by 3, or etc., so that I can isolate one of the variables. But being that this time I've chosen to do it by elimination, I have two choices. I can multiply two different things. If I take equation 1, I have a choice of what I can multiply it by. What are my two choices? Let's get someone else, because you've been really good so far. Have a look. You can choose two different things to multiply this by that will both work. Yeah, Jazz, you want to give it a go? Okay, 2 and 3. Let's have a look at this. Why would I multiply by 2? How would that be helpful if I multiply by 2? I'm going to end up with 6x minus 4y equals 22. Is that going to be useful to me? Now, but it might be useful depending on what coefficients I have in the second equation, right? As it so happens at the moment, I look and I see, well, that's a 4, that's not going to go into 6. That's a 3, that's not going to go into 4. So I'm going to need to go to another option. Now, the other suggestion was 3. 3 will work, right? Why is 3 useful? What's the feature about the second equation that's actually going to help me here? Yeah, right now.
3y.
Fantastic. So I see that this doesn't have a 3 in it, but this does. Okay, so 3 works. What am I going to get? I'm going to have 9x minus 6y equals 33. Okay? This is going to work because I'm going to be able to do something here. Now, I'm not going to pursue it. You tell me why in a second why I'm not going to. But what was my other choice? It's not 2. What else could I multiply by that will still work? But it's just not that great. Yeah. 4. Very good. I heard it a few times. 4 will also work for the same reason that 3 will work. It's just that it will mean I will eliminate the x instead of the y. I'm going to avoid that though. I can think of at least 2 reasons why I'm going to avoid the 4. Can anyone tell me why? Any one of the reasons? There's 2 reasons, yeah.
It's really big.
Number 1, it's a bigger number. I know 3 and 4, relatively the same, but they're not always so clean cut, okay? So number 1, it's a bigger number. Another suggestion why I want to avoid that? It's a pretty minor one. If I were to multiply by 4, then what I'm going to have to do to these two equations is I will have the same number of x's here and here. I guess I'd have 12x and 12x, right? Then I'm going to have to subtract the equations in order to cancel them. Yeah, so I'm going to have to, I'm just going to try, I told you yesterday, right? I avoid subtraction wherever I can. Not because there's anything wrong with it, but because it's error prone. Every time you add in a negative, every time you add in a minus that's going to multiply by another minus, you're asking to get something wrong, okay? So that's why this is a better choice. This came from equation 1, so can I have a suggestion for what I should name it? 1a, that's a perfect name. Okay, in just the same way I'm going to have to multiply equation 2. In order to have something equivalent, I'll multiply this one by 2. Okay, so don't forget to multiply every single term. That's another easy error to make when you're doing the elimination method. And being that that came from equation 2, I'll call that 2a. So now my stars have aligned. I have the negative, the minus 6y here, the plus 6y there. So now I'm just going to add the equations together. Okay, adding is always a better way to go. So I'm going to get, excuse me, 17x here. My y's cancel. What do I get on the right hand side? 119. Okay, so x is going to be equal to... Now, before you look at it and think, oh, I need my calculator for this one, okay? Sure, get your calculator eventually. But you need to exercise that muscle, otherwise it's going to atrophy. And there's an easy way to see it must be 7, right? What's the easy way to see that it must be 7? Because you look at the 9. You're like, what can multiply by 7 to give me a 9 on the end? It would be 7 times 7 is 49, right? And then I've got some extra, and then you mentally check it out. 70 plus 49, yeah, it works, okay? So it's an easy division. Don't reach for the calculator if you don't have to, okay? Just like before, I'm going to take that and I'm going to substitute into... Any suggestions? Where do you think is the best way? I actually think it's kind of equal here. 1 gives you smaller numbers, but you got negative. 2 gives you bigger numbers, but everything's positive and nice and neat. Just because you asked for it, let's put it into 1. So what am I going to get there? 21. Yeah? So I've got a negative 10 over there. Does that check out? Cool. There you go.